Okay, from this video onwards, we're going to be looking at accuracy measures for classification problems, which means our target variable is a binary variable, or it could be nominal, but mostly binary, 0 or 1. So we'll start with a very simple problem where we have a riding lawnmower example, where the actual class is whether a household is a owner or a non-owner. That's the actual value, actual Y value. Now, using any of the data mining methodologies, we can come up with, based on a set of predictor variables, we can come up with a predicted probability of owner for each of those cases. Okay, so we're going to assume some probability values from the textbook, but in later chapters we're going to see how to calculate those probabilities. Okay, right now let's assume that we use some method and we've already generated those probabilities. So we now have the actual classes and then the probabilities that we have calculated predicting the class. Okay, so for example, in the first case, we are predicting that the first case will be a owner with a probability of 0.9959. The actual class is owner. So in this case, like this one, we are predicting that the probability that this case is a owner is 0.7628, but the actual class is non-owner. So if you have a cutoff probability of 50%, then you will predict that this one is a owner. But actually, it turns out that that property is not a owner. So there is an error in classification here. That's what we're going to study. So if you look at the look at this one, the probability that it is a owner is 0.2179. So if the cutoff probability is 50%, you will predict or you will classify this observation as a non-owner, but in reality it turns out to be a owner, and again there is a conflict there. Okay, and that's what we want to analyze. Okay, we are not going to look at how to generate these probabilities at this point in time. So we will do that in later chapters. So we start with, if you see that, one of the, okay, right here, like, see these two clickable icons that will maximize or shut down, or not shut down, but make it not display the window. So here console is only displayed, but your source is not displayed. So you have to go click that, and the source will expand. Now the console is not shown. So here, if you click that and you click that, then you get both of them. So first thing first, we set the path, okay, to the folder containing our data files, and then let's set up some libraries. Okay, so we're going to set up these libraries, all of which we have seen except for E1071 that we need in the case of classification. So let's run these. Okay, so then let's load the data. Okay, owner.df assigned to read.csv. Okay, owner example .csv, that should be within quotation marks. All right, so we have, it's a very small example. So there are just 24 observations, the actual class and the probability that we are using for prediction. So to set up confusion matrix, okay, a confusion matrix, there is a function in caret for confusion matrix. Okay, and the confusion matrix takes in two columns of input. Okay, the predicted column and the actual column. So you need to give prediction actually. Okay, so not probability. You need to give prediction. So before we can use confusion matrix, we have to set up our predicted column. Okay, and so for predicted column, we need to have a cutoff. So let's say cutoff is 0.5, 50%. So if your predicted probability is more than 50%, then you'll classify as owner. If it's less than 50%, classify as non-owner. So in that case, okay, we can set up our prediction. So we'll call it as prediction, PRED. Okay, so we are now going to have to compare. We have to look at the probability, right? So owner.df probability is what we have to look at. Then if it is greater than 50% owner, otherwise non-owner. So this is like the Excel if function, and the Excel if function in R is if else. Okay, so we do if else. Okay, if this probability is greater than cutoff, okay, so we have set up cutoff as 50%. Okay, then we say owner, right? Otherwise, non-owner. Okay, so that would set up our prediction for us. Okay, so now we run these two lines of code, then we have the prediction, right? Then we can run the confusion matrix. So first item is the prediction. Okay, now we have to, this should go in as a factor, so we have to convert the prediction to a factor. Right now it is just a character variable, so you have to change it to factor. Okay, now I have an extra, okay, confusion matrix as factor spread, right? And then as factor owner df class. Okay, let's make sure the parentheses match up. So that one doesn't need to be there. So now if I run, so I get the results. Okay, so here is our accuracy. This is your confusion matrix. And then we have all the other performance measures. Okay, and then our predicted class, positive class is non-owner. Okay, so now